Hello students, so now we are going to the previous year question session of the chapter number 7, which is the alternating current. Let's begin the question. The first question is, in the circuit which is shown here, the point C is kept connected to point A till the current flowing through the circuit becomes constant. Afterward, suddenly point C is disconnected from the point B and time t is equals to 0. Ratio of the voltage across resistance and the inductor at t is equals to L by R will be equals to, this is the diagram where R is the resistance. These are the options. So the correct answer for this question is option 3. So let us see the solution of this question. That I is equals to I naught e to the power t by R in the minus. This is the value of a current during the charging or a connection or disconnection ratio. So we know that VR by VL is equals to IR divided by L di by dt. If I just put all this value in the terms, we got the result VR by VL is equals to R tau by L. The value of this is a minus 1. According to this, the correct answer for this question is a minus 1. The next question we have, in the circuit A and B, switches S1 and S2 are closed at t is equals to 0 and are more kept closed for a long time. The variation of the current in two circuits for t is greater than or equals to 0 are roughly shown by the figure. This is the diagram of that. So like in the first circuit, as you can see, where we have using the capacitor, and in the second section we are using the inductor. This is a capacitor and this is the section of inductor, and the R is in both sides. So these are the diagram which is actually represented like E by R diagram for that. So let us see the solution of the part. For the correct answer is E by R. See, circuit for like I is equals to I naught e to the power minus t by RC, that we know. And at the point B, this is the case of a capacitor. And this is the case of an inductor. This is the case of a current when R and C will be present over there, and this will be the situation when L and R will be present over there. So according to that, as we know, the graph will be for a first one minus t by RC and for the second one minus t by L by R. The second option is the right answer. Next question we have, for LCR circuit which is shown here, the current is observed to lead applied voltage. An additional capacitor C, when joined with the capacitor C present in the circuit, makes the power factor of the circuit unity. The capacitor C must have been connected here. We have an options are series with C has a magnitude 1 minus omega square LC by omega square L. Series with C has a magnitude C by omega square LC minus 1. Parallel with C and magnitude C by omega square LC minus 1. Parallel with C and has a magnitude 1 minus omega square LC by omega square L. So this is the diagram is given. Students, the correct answer for this question is a 4. Now, I'm going to explain like how this will become. So, if I'm just taking the diagram in this section, so as we know that if this will be a resistance, so voltage is leading at a pi by 2 phase difference with the VL, and VC is lagging at a pi by 2 phase difference with this. So, as the current lead voltage turns, since the power factor has been made to be 1. So, for that, effective capacitance has to be increased. Thus, connected in parallel, that means cos phi is equals to 1 and I omega L is equals to I by omega C plus C prime. So C plus C prime is equals to 1 by omega square L. C prime will be what? 1 by omega square L minus C, and C prime after solving that will become 1 minus omega square LC by omega square L in the parallel. So the correct answer is the fourth one. I hope you understand. The next one we have for LCR circuit shown here, the current is observed to lead the applied voltage and additional capacitor C when joined with the capacitor C present in the circuit makes the power factor of the circuit unity. The capacitor C must have been connected in 100 milliampere, 67 milliampere, 6.7 milliampere or 0.67 milliampere. The question is the capacitor C prime must have connected in this. So the correct answer for this question is 0.67 milliampere. Now move with the solution part. So let us see the solution of this question. I naught is equals to E by R, that we know, and after putting this value 0.1 ampere came in the region. Now tau is equals to L by R. If I just put the value of L and R, the answer will become 2 10 to the power minus 4. Decay rate, as we know, I is equals to I naught. This will becomes, so e to the power minus t by tau takes place. If I'll just put all these values over there, the answer will become 0.67 milliampere. And hence we can say that the correct answer for this question is the fourth option. Next question we have 4 bulbs B1, B2, B3 and B4 of 100 watt each are connected to 20 volt main as shown in the figure. The reading in an ideal ammeter will be this 0.45 ampere, 0.90 ampere, 0.135 ampere, 1.80 ampere. So the correct answer for this question is a 1.35 ampere. Now moving ahead with the solution part. So total current supplied 220 and the R equivalent. So as we know that all these resistors are in the parallel, so the resistance equivalent will be R by 4. After putting the value, we get the value of the total current, which is a 1.8 ampere. And the current in each, that is a 1.8 by 4, this will be 0.45 ampere. And for the third section or for the 3 section only, this will be 1.35 ampere. I hope you understand like how I'll just solve this particular problem. The correct answer for this question is, we can say according to this, option number 3. The next question we have, when the RMS voltage VL, VC, VR are connected or measured respectively across the inductor L, the capacitor C and the resistor are in a series LCR circuit connected to an AC source. It found that the ratio LCR circuit connected to an AC source. It is found that the ratio of VL, ratio VC, ratio VR is equals to 1 ratio 2 ratio 3. If the RMS voltage of the AC source is 100 volt, then VR is close to, we have an option 50 volt, 70 volt, 90 volt and 100 volt. So the correct answer for this question is, with the solution V is equals to, we know that for the complete magnitude that will be completed as a under root VR square plus VL minus VC whole square. If I just put all these value together, we get the value of a K, which is a 10 root 10, and we are 90 volt. According to that, the correct answer is 90 volt. Next question we have, a sinusoidal voltage Vt is equals to 100 sine 500t is supplied across a pure inductance of a L is equals to 0.02 Henry. The current through the coil is 10 cos 500t minus 10 cos 500t, 10 sine 500t and minus 10 sine 500t. Solution of this question is, we know that I is equals to minus I naught cos omega t, or we can say minus E naught by omega t cos omega t. So if I just put all these values together, we get the formula like the minus 10 cos 500t. So the correct answer for this question is option 2. Next question we have. A series LR circuit is connected to an AC source of a frequency omega, and the inductive reactance is equals to 2R. A capacitance of a capacitive reactance is equals to 2R. A capacitance of a capacitive reactance equals to R is added in series with L and R. The ratio of the new power factor to the old one is, we have an options, root 2 by 3, root 2 by 5, root 3 by 2, root 5 by 2. So, the solution part, let us see. Power factor is a cos phi used as a phase diagram or a phasor diagram. So cos phi 1 is equals to R by Z1, or R by under root R square plus, because here the resistance will be 2R as you can see over there. So R square plus 2R whole square. This will becomes R divided by under root 5R square. Answer for a cos phi 2, this will be R by Z2. This will be R divided by R square plus 2R minus R whole square. This will becomes 1 by root 2. So cos phi 2 minus cos phi 2 divided by cos phi 1, this will becomes we have to ask the power factors ratio to the old one to the new one. So that will becomes 5 by root 2, like under root 5 by 2. So the correct answer for this question is option 4. Hope you understand. Moving with the next question. When resonances are produced in the series LCR circuit, then which of the following is not correct? Current in the circuit in the phase with applied voltage, inductive and capacitive reactance are equal. If R is a reduced, voltage across the capacitor will increase. Impedance of the circuit is a maximum. So, let us see the solution of this question. At resonance, we know from the earlier basic concept like XL equals to the XC. So for that, we can say the correct answer is option 4. Next we have the plot given below is the average power delivered to an LCR circuit versus frequency. The quality factor of the circuit is, so this is a diagram which is between the average power and a frequency. Option 5, 2, 2.5 and 0.4. So the correct answer for this question is second. Solution, let us see. Quality factor or Q factor is equals to resonant frequency divided by bandwidth. That means F0 divided by F2 minus F1. Next question we have, in a series LCR circuit, C is given 10 to the power minus 11 farad and L is equals to 10 to the power minus 5. R is equals to 100 ohm. When a constant DC voltage is applied to the circuit, the capacitor acquires a charge 10 to the power minus 9 coulomb. The DC source is replaced by a sinusoidal voltage in which the peak voltage E0 is equals to the constant DC voltage E. At the resonance, the peak voltage or a peak value of the charge acquired by the capacitor will be 10 to the power minus 10C, 10 to the power minus 8C, 10 to the power minus 15C and 4 10 to the power minus 6C. So, solution part we have Q is equals to EV. E is equals to Q by C. If I just put all these values, we get the answer like 100 nu. So 100 V. So I is equals to E naught by R, 100 by 100, that would becomes 1 ampere. And Q is equals to, for the quality factor, that Q is equals to 1 by 2 pi under root 1 by LC. If I just put all these value together, we get the value of a VC Q, that is a 10 to the power 8 by 2 pi. This is the value of a Q. This is the value of I naught. And we know that VC is equals to I naught XC. So I just put this value of IXC with the I naught which we calculated over there. The answer will become 10 to the power minus 10 to the power plus 3 volt. And omega is equals to 2 pi f. So we can find the value of omega also, which is a 10 to the power 8 radian per second. So Q naught is equals to CVC. That's why we need each and every term. C, we calculated over there, like we know C is given already. VC, we calculated, and we just put this all value and get 10 to the power minus 8 coulomb. I hope you understand like the steps of doing the question. So the correct answer will be second option. Again, why we just need the value of Q? Because if we just want to equate this value Q, so that we can easily get the value of another terms for a I naught. I naught, E naught and R required. Similarly, if I just want to be with the VC, so again XC required. So all these values are like in the bond up together. That's why we need each and every terms. Next question we have. An LCR circuit as shown in the figure is connected to a voltage source VAC. Those frequency can be verified. The frequency at which voltage across the resistor is maximum: 23 Hz, 345 Hz, 902 Hz, and 143 Hz. The correct answer is 23 Hz. Let us see the solution of this question. So resonance condition F is equals to 1 by 2 pi under root LC. So F is equals to 1 by 2 pi under root. The value of L and C is given already. We just solve this term and get the value of frequency, which is 23 Hz. Next question we have. In the circuit shown here, the voltage across L and C are respectively 300 and 400. The voltage E of the AC source is 400 volt, 100 volt, 700 volt, or a 500. The correct answer for this question is with the solution part. E is equals to under root VC minus VL whole square. So if I just put all these values together, the correct answer will become in the 100 volt. Hence, the second option is the correct answer. Next question we have. In an LCR circuit shown in the following figure, what will be the reading of the ammeter across the resistor? An ammeter if an AC source of a 220 volt and 100 Hz is connected to it as shown in this diagram. So there will be options are 800 volt with the 8 ampere, 300 volt with the 3 ampere, 220 volt with the 2.2 ampere, and 110 volt with the 1.1 ampere. The correct answer for this question is 220 volt with 2.2 ampere. Let us see the solution of this question, like how this will become. So at resonance, this is a very basic value now. I think you will be know about that XL is equals to XC at the condition of a resonance. So VR is equals to V net. That means across the resistor, how many potential that we can use actually. So that will be 220 volt. Ammeter reading VR by R. So 220 by 100, 2.2. So we can say the correct answer for this question is that was 15th number question is. An our lamp required a direct current of a 10 ampere at 80 volt to function. If it is connected to a 220 volt RMS 50 Hz AC supply, the series inductor needed for it to work is close to options 80 Henry, 0.08 Henry, 0.044 Henry, and 0.065. So the correct answer for this question is the fourth. Solution part is, this is a circuit which we saw earlier. So V square, like a 220, the main voltage square is equals to AT square plus VL square. For this situation, if I just want to calculate the value of VL in the magnitude, so that will become 220 square minus 80 square. That means 10 under root 22 square minus 8 square. So VL will be IXL. So if I just put this value VL, which we calculated in the equation number 1, and from this, so the answer L is equals to comes under root 22 square minus 8 square, 2 by 22 by 7 into 50 is equals to 20.49 divided by 100 into 22 into 7. That means the value of L is 0.065 Henry. Next question, we have a series LR circuit is connected to a voltage with Vt is equals to V naught sine omega t. After a very large time, current IT behaves as a T is a greater than L by R. For this situation, this is the diagram, or these are the diagram, among which one is the correct? So the correct answer is the fourth one. This is all about for the today's class, student. I hope you enjoyed this session of the previous year questions. So soon we will come with the previous year question session 2. Till that, take care everyone.